with n equals 4 or 4 intervals, return to 4 rectangles, we can manage those computations. But let's just say that if we want to estimate the area under the curve using 100 rectangles, 1000 rectangles for example, because the more rectangles we use, the better the estimate. The better estimate, the less error. The lesser error, the more exact the approximation will be. But it is almost a daunting task to have to add 100 terms, 1000 terms. And let's assume for a moment that we do not have access to a calculator that gives us the integral notation. Many of you do. We know from the definition of the definite integral, the integral from a to b of f of x dx is the limits at n go to infinity of the sum as I go from 1 to n f of xi times delta x. This is called the Riemann sum. To set up this Riemann sum, we would need to know what xi is and delta x. Delta x is always b minus a over n, where b and a are limits of integration given in the definite integral. X naught is always a, the lower limit of integration. The increment is delta x, so x1 is a plus 1 delta x, x2 is a plus 2 delta x, x3 is a plus 3 delta x. So xi is a plus I delta x, but delta x is b minus a over n. X sub n should be b. That is, xi is a plus I delta x, where delta x is b minus a over n. If we were to use the left sum, then we use the height on the left-hand side of the first subinterval, the height on the left-hand side of the second subinterval, and the height on the left-hand side of the last subinterval. Thus, the left sum is the sum at I go from 0 to n minus 1 of f of xi times delta x, where f of xi is f of a plus I delta x. If we use the right sum, then we use the height on the right endpoint of the first interval, the right endpoint of the second interval, and the height on the right endpoint of the last interval. The right sum is therefore the sum at I go from 1 to n f of xi times delta x. This is the same formula at the left sum, but we start at I equals 1 and n with n. We still have n terms in the sum, n terms in the sum. For example, to estimate the integral from 1 to 2 of e to the negative x squared dx without knowing what n is, we first set up the Riemann sum, where delta x is b minus a over n. We don't know what n is. Delta x is therefore 1 over n. xi is a plus I delta x, where a is 1, plus I, and delta x is 1 over n. Thus xi is 1 plus I over n. The height is therefore f of xi, but f of x is e to the negative x squared, where xi is 1 plus I over n, and we square this. We have the width and the height for each of the rectangles. Using the left sum, we would set up the sum at I go from 0 to n minus 1 of f of xi, which is now e negative 1 plus I over n squared times delta x, but delta x is 1 over n. The right sum Rn is the sum at I go from 1 but to n, e to the negative 1 plus I over n squared times 1 over n. For example, if we want to use 4 rectangles, then the left sum L4 is I go from 0 to 3. 0, 1, 2, 3. And we would replace the n with 4 in the formula. For the right sum with n equals 4, we would go from I equals 1 to 4 and replace n with 4. If we do that, we would get L4 equals 0.182415 and R4 is approximately 0.095024. For the midpoint Mn, the delta x is still b minus a over n, but the midpoint xi bar is 1/2 of xi minus 1 plus xi, although this is not useful. A useful one to set up the sum is a plus I minus 1/2 times delta x. The midpoint estimate Mn is approximately the sum at I go from 1 to n f of xi bar times delta x, where delta x is the width and f of xi bar is the height using the midpoint, where the midpoint xi bar is a plus the quantity I minus 1/2 times delta x. To estimate the integral from 1 to 2 of e to the negative x squared dx using the midpoint rule, we first find xi bar, where xi bar is a, which is 1 plus I minus 1/2, and then the delta x is still b minus a over n, or 1 over n that we found earlier. The midpoint estimate Mn is approximately the sum at I go from 1 to n, f of xi bar times delta x, but f of xi bar is e to the negative 1 plus the quantity I minus 1/2 times 1 over n squared, and delta x is still 1 over n. If n equals 4, then xi bar is 1 plus I minus 1/2 times 1 over 4. This is 1 plus 1 over 4 times I minus 1/2. There's no need to simplify this. Thus, M4 is the sum at I go from 1 to 4, e to the negative. The inside the bracket is now 1 plus 1/4 I minus 1/2 squared this times b minus a over n is 1 over 4. Put this in the calculator, we would get 0.133522.